to quickly recap what we did last Thursday. So I want you to think about the following question, in a minute or two. And if you could share with the rest of the class, what you're thinking, that would be great. Say you're given a function in general. All right, so whatever you understand about a function back in the college algebra, what does it mean to invert it? Or what are you looking for as an inverse function? Or maybe another way to put it, what does it mean when you're looking at an inverse function? What does it mean to you? Right? In a few words, you can use your own words, doesn't matter. You don't have to use those professional terms as long as it makes sense. Right? So again, think about if you're given a function in general, what does its inverse function represent or mean to you? All right. Give me a second. Let me finish the attendance, then I'll get back. All right, you guys think about that. Feel free to discuss with the people around you. All right, it's not gonna be some kind of serious a quiz question. Yeah. I don't have it with me, but I'll get you that if I remember next time. Yeah, but I do have something else. Which, yeah, you're good, but later. Yeah, but that is the graph for 5.6. All right, give me a second. All right. Again, my question is, what does a inverse function means to you? Hello, everyone. All right. All right, anyone's ready to share? Well, it has to be volunteers. Now, just to make it a little bit easier for you guys to refer to when you're trying to explain it to me or to the rest of the class. So how about we think about some easy functions? Say the function f of x is just 2 times x. And what do you think will be the inverse of it? Max? 2 divided by x, or is it the other way around? X over 2, right? X divided by 2, yeah. All right, so now this is where you can think about what you have done to a function in order to invert it, right? And now in your own words, what do you think that inverse function is trying to do? What does it mean to you? Anyone feel like sharing some thoughts? Alexia? To the original function, right? Good. So now I still find that opposite is kind of a professional, and also at the same time it's kind of vague. Would you mind telling us that? What does it mean, like being opposite? Like in what way? Okay, so it's the opposite or the reverse process, reverse operation, right? Yes, and that's why you see that here. What the function f is trying to do to the x, keep doubling it, right? Multiplying the x with a 2. Anything you put into the f of x, it will multiply that with a 2. Now the inverse is try to undo, right? Or to reverse, right? Instead of multiplying by 2, it will divide the input by 2. That means if you take the output from the f and feed it into the inverse, it will get you back the same input you started with in the first place, right? So it's like, nothing had happened, right, to the x. So I was telling the second period is like, people don't like functions, or maybe when it comes to inverse, it's also, kind of a, non-intuitive. But think about that. Maybe we like an inverse function in our life because it can undo whatever you've done that you regret it, right? So whatever you've done, just put it in the inverse and it does it for you, right? And like I said last week, the shortcut in the computer, Control Z, right? So whatever you did, you can even try just the Control Z anywhere, right? Maybe it will just undo whatever you've done. Anyway, and it turns out that logically, this is good enough for you to understand the inverse trig function. But the reason why we still have to learn it, because there's still some little detailed subtleties you have to know. Knowing the logic is not good enough, but it's definitely going to be something you want to start, right? Now, let's take a look at what we have talked about the sign and how to invert it. So right off the bat, to invert the sign, we need to know what the sign looks like, okay? So this is the graph, right? It's about the best way to understand a function. So we see that there's something wrong with it. It does not pass the horizontal line test, right? If you draw a horizontal line, it intersects the graph at so many points. But what's wrong with that? It is a function already, right? Why do I have to be so nitpicking when it comes to, like a multiple inputs, right, for the same output? So the example I used last week is ask yourself what the sign is going to tell you if you want the output to be 1/2. So that at what angle you think that sign is going to be 1/2? You can even see from the graph, right? It could be an angle somewhere here. If you happen to know that sine of 30 degrees is 1/2, right? Does it make sense that it's somewhere between 0 and a pi over 2? Pi over 2 is 90 degrees, right? Between, it's a acute angle. But then you say, wait a second. You can also get 1/2 at this angle. You may or may not know that it's 5 pi over 6 or 150 degrees. Okay, you can try in a calculator. You know what? Wait a second. This one also works out, right? That's even greater than 360 degrees, right? Not to mention, there's an angle here, which is negative. I'll tell you, it's negative 210. So there's so many angles, right? So now, again, think about a question. You want an angle, right? So that sine is going to be 1/2. But guess what the function is going to tell you? It tells you actually infinite many angles. Then what's the point of having a function like that, right? Therefore, a quick fix. The fix you have to do to the sign to make sure that it's invertible. So it means its inverse is going to tell us a definite angle given whatever number you want, say 1/2, right? It has to tell me, 30 degrees or pi over 6, no more. And what we did was to restrict the domain of the sign. Let me draw 2 vertical lines. All right, so we're only going to focus on the center part of the graph of the sign that starts from negative pi over 2, with a value of a sign is -1, all the way to pi over 2, where the sign is its maximum, right, at 1. So just trim the graph. Forget about those parts. They're to the left of the first vertical line, and a part there to the right of the second vertical line. All right, just take that part. And you see how nice that part is? It's rising, right? It's 1-to-1. By 1-to-1, I mean pick an angle. Say here, 30 degrees. You see that it returns 1/2. Are there any angles that are going to return 1/2? No, because we already forget about all those excessive, inputs. And that's an easy fix. Pick the part of graph that's 1-to-1, and it's going to be usually rising or falling the whole time, right? But it's not going to be rising or falling at the same time. Okay. Now, the inverse sign is supposed to tell us the angle. But the thing is, the sign is taking not for an all real number anymore because we restricted the domain that's going to from negative pi over 2 to pi over 2. But don't you think once you invert the graph, once you invert the function, the output of the inverse function must be within the same interval? Because remember that these are the possible angles, right? You put into the restricted version of the sign. But if you invert the sign is going to spit out an angle, and it better be somewhere in between this range, right? Now, let's check if that logic works out. So they say that we're going to invent a new function. It's called the inverse sine. And the notation is kind of funny because you thought that it's raising the sine function to the negative 1 power, right? You thought it's cosecant because, it looks like a reciprocal. It's not. It's just a notation, right? They named the function after the sine. They put an inverse power there to remind you that it's the inverse of the sine. So now you're looking at a function. So that just magically returns the angle you want as long as you specify what kind of ratio you want. Say 1/2. Sine inverse is going to take 1/2, then spits out an angle at 30 degrees, if that's what you want, right? And you can try maybe sine inverse of one of the special angles, 60 degrees, right? You may or may not remember sine 60 is radical 3/2. Well, what if you feed radical 3/2 to the inverse sine? What do you think that's going to spit out? What angle? Sine is going to be radical 3/2, but isn't just that 60 degrees? That's what the sine inverse is trying to do, right? But see that, if the special angles, we are able to memorize it. Otherwise, we have calculated. But does it make sense to you now that inverse function, notice I'm talking about the inverse function, will be in a range of negative pi/2 to pi/2. Do you see that? It is the restricted domain, right? The part of the domain that we picked and we trimmed out from the regular sine graph. But now that was the restricted domain of the sine function, and it becomes the range of the inverse sine, because sine and inverse are doing the opposite thing, right? One takes the angle, sine function takes the angle, gives you the ratio, right? But the inverse sine is going to take the ratio and gives you the angle, right? That's why the angle better be in the range you want it. Now, what about the domain of the inverse sine? Does it surprise you that the domain of the inverse sine is negative 1 to 1? Where did it come from? The domain of the inverse sine is nothing but the range of the regular sine, right? And it has been negative 1 to 1 ever since you've learned, the sine function, right? See that it just takes some time to get used to switching the mind from going one way to the other, right? All right, so I guess this is something I want to quickly recap. That's what we did, but it was covered quite a few days ago. So now I think that you're ready to quickly respond to some of the questions that are asking you, hey, what is the domain? What is the range of the sine, of the inverse sine, right? Things like that, right? But before I do that, any questions so far about how you're going to do the logic, or is there any part of the logic that still bothers you? I don't think so. It's just, you have to get used to it, right? Anyway, again, the first 4 questions, you're going to get the same exact options. Top left, top right, bottom left, bottom right, okay? Well, the first question always going to be a warm-up, but I hope that you guys remember that these are interval notations, even though that here we have the inequality version, right? But these are the same. Okay? All right, so let me put this up. All right, so please, we have a small class, everyone join the Kahoot. Yep. Say it again. All right. All right, go ahead. We have 12 students. Yeah, just so you know that we always hope that at least there will be one question that everyone's going to get it right. you know, we're so close every time, but it's always going to be, you know, some imperfection, right? But again, you know, in this case, again, I won't blame you if you got confused, because, I mean, those questions are designed to tease your brain a little bit. All right, so we're waiting for 2 more students. All right, cool. Let me lock this. Wait, what does it mean? Hmm. All right, so let's get started. Wow, this is so close. Anyway, like I said, you know, I don't blame you. You know, if when you seriously try it, right, under pressure, then things get still a little bit shaky, right? The range of the sine function, right? Think about the function goes up and down, right? The amplitude is 1, it goes from -1 to 1 because it's the range. So I guess that, I mean, I guess people are, you know, because I keep alerting you guys, hey, the restrict domain. So it's like the only thing that in their brain is restrict domain, right? But it's the range, right? Let's see who's the, okay, good job, Ashley. All right. All right, you guys for the next one? Yes, yes. Let's see who's gonna laugh at the end. Calm down and think. Okay, see that whenever it comes to inverse or now the fancy term restrict domain, right? People start to, you know, hesitate, and since it's time, so that's why, you know, if you give it like another 10 seconds, I think you'll figure it out. Yeah, in this case, the restricted domain is the part of the graph of a sign that we picked in order to invert it, right? So again, think about the word restrict, because science is giving you too many ambiguity, right? Too many inputs. So you want to restrict it, right? Stop telling me those angles. I want 30 degrees when you want the sine to be 1/2, right? All right, so all right, next one. Well, let's see if any changes in the, okay. Good job, Ari. All right. Well, soon you guys gonna compete with the time. All right, let's see. Go ahead. Get ready for number 3. All right. Now it's definitely, you know, was expected in general, since again now you're seriously dealing with the inverse function, right? Do you guys remember that when we deal with those functions that you're not very happy with, like cosecant, secant, and cotangent, you guys are pretty good at using the reference function, right? Whatever function closely related to those guys. Say whenever you think about secant, or whenever I think about secant, I'm thinking about the cosine, right? Cosine and secant are reciprocal. So whatever you know about cosine, it applies to secant, right? Almost. So in this case, instead of asking yourself, what is the range of the inverse sine? So you focus on the inverse sine. It's the non-intuitive thing, right? Why don't you think about the domain of the sine, right? But here's the catch. It's not the domain of the sine. It's the restricted domain of the sine, right? Because, you know, if you don't restrict the domain of the sine is not even invertible, right? There you go, right? The restricted domain of the sine is this guy, right? No. I mean, good thinking, because now you're thinking about, okay, things has to be consistent, right? And you're trying to find the consistent things later on for cosine and tangent. Do you think of that way? Because there are two more, right? Yeah, unfortunately there. Yeah. One more question like that. Okay, well, good job, Ashley. All right. Go ahead. Okay, so finally, you guys are back to the normal track. All right. So now the domain of the inverse. If you're like me, that I want to switch my mind and think about the sign, right? So we're thinking about the inverse sign. Domain of the inverse sign must be the range of the sign, right? That's actually the easy part of the sign, right? It goes from -1 to 1, and there you go, right? All right. Last question. And it's not going to be about those domain and range anymore, even though that you better think about them. So now it will be the kind of question I keep using to remind you what we're supposed to do with the inverse sign. So I said, at what angle the sign is going to be 1/2? You know, it's going to be 30 degrees. No, will be the same kind. So I want to make sure that you think, you already start to switch your mind. So you see, that's the same question. You know, sine 30 is 1/2. But if I ask you, at what angle sine is 1/2? 30, right? So then now you will see a different ratio. It's not going to be 1/2 anymore. You have to think about one of those angles, right? Four of them, they're all angles. And you know what's worse? They're in radians. Yeah. All right. Hey, you know, that's the reality you have to live in. All right. So we do radians a lot more than degrees. Anyway, so there'll be four angles showing up in radians. They have pi in it, just so you know. So there are some kind of special angles. You have to think about which of those angles is going to get you the sign to be exactly what I want, right? Just like, hey, pi over 6, which is 30 degrees, right? That's going to get you the sign to be 1/2, right? Let's see. All right, but first, you know, let's see who's. Okay, let's do Ashley. All right. All right, so let's do this. Go ahead, guys, calm down. All right. All right. Now, how does it work? You know, I hope that you guys are thinking. We're talking about you. I thought that you're gonna ask me at what angle would sine be certain things, right? But we don't do that in the test. We don't do that in SAT. You have to understand the notation, right? What does it mean to you? Sine to the -1 power. It's the sign. It's the inverse sign, right? It's taking what? It's taking the ratio you wanted, right? It spits out an angle. So now, isn't that just asking you at what angle sine is going to be 1? So now if you think about at what angle sine could be 1, it's the maximum, right? Because remember that we use the sign to model the periodic behavior while we always look at the maximum minimal. So I hope that even though it's not one of those special angles, not 30, 60, 45, it's 90 degrees. All right, sine 90 is 1, or sine pi over 2 is 1, right? But again, I don't blame you. You don't have to remember these things right away, right? You have graphs, you have scientific calculator, right? You can take your time to look things up, you know, from a textbook, right? But let me put it this way. So are you expecting a question like that in a test? In our test? Unfortunately, well, there might be, but not very likely, because think about this, you know, like I said, you guys will start to use scientific calculator on our tests, right? This is as simple as just type in sine inverse 1, it returns 90 degree, right? Pi by 2, right? There's no hope, there's no point of it, having a question like that in the test anymore, right? Yeah, I'm sorry, I always bring you guys the bad news. Better be prepared, right? So for the worst part of life. Anyway, well, let's see, who's the winner. All right. Congratulations, Ashley, and good job, Alana and Amaya. All right. All right, cool. So now, but let's remember the whole process of thinking through those logics, right? And definitely it works out, with the sine and inverse of sine, right? But what didn't work out is the time. But I think that this is, one of the major issues that, most of our students are having our test or even the SAT, right? Anyway, so now let's do the same thing that we have done to the sine. So we'll, do the same thing to the cosine and then tangent, right? Now let's take a look at the cosine function. So again, to invert it, let's see what's going on with the cosine. Right off the bat, do you guys see what's wrong with the cosine when it comes to inverting it? It doesn't pass the horizontal line test, right? If you draw, I wish I have a straight edge, right? So if you draw a horizontal line, it will intersect the graph at infinite many points. It tells you, just like the sine, if you ask for a certain ratio, let's say 1/2, it will return infinite many angles, right? You don't want that. Remember the easy fix? We trim the graph of the sine, right? We pick either the rising part or the falling part. Now, when it comes to the cosine, we do the same thing. But unfortunately, if you pick the rising part, you have to deal with negative angles. So I mean, then it's nothing about which is better or not. Just a convention. Yes, go on. Over what you said last week so that we're not lost in the next. Well, yeah, for some of the topics, we'll do that because now, do you guys realize that it's not hard, but it's frustrating, right? You do understand and you think you remember, but as soon as you start to get a little bit stressed out in a time test, right? You don't get it, right? So, and this is only when that we're probably gonna do this, like maybe every week, every once a week. But later on, trust me that you will see in our second test, you don't have to do those kind of memorization or kind of a funny logic to figure things out. It's like if you already know what you have been doing, in our class when it comes to thinking, you should be able to do well in our test. But it's just that there's no way I can tell you that you'll be fine before you actually try the test. But don't sit down and relax if you're like that, oh yeah, since Dr. Ron's gonna prepare for a test, so I will be fine. But you have to do your own part by, going over those questions, if you do understand them, right? Like I said, there's nothing hard to understand them. But the question is, are you able to get it right within, very limited amount of time, right? And do the cool quiz, not just because I want to show it to Ms. Cameron, it's also to let you know that go through the process, yeah. But go through a process and see that there's a way to make it quick, because now you realize that, hey, instead of thinking about inverse sine, think about the sine, right? Anyway, so now mathematician pick that part of the cosine graph that starts at 0, ends at pi. So forget about the remaining part. So the restricted domain of the cosine is from 0 to pi. But unfortunately, the graph is going to go down. So it starts at 1 when the angle is 0 and stops at -1 when the angle is pi. Right? But at least that angles are positive. If you're just looking at the trimmed part of the cosine graph, right? Only that middle, not the middle part, right? Only from 0 to pi. What do you think will be the range of inverse cosine? the restricted domain of the cosine, which is right there, right? So, but again, if I were to ask you in a Kahoot, you're not supposed to look at this. You're gonna have to think, right? But I mean, that's not supposed to be what's gonna be like, when you become a professional, right? You don't have to, like memorize and everything, right? Have a reference sheet. What about the domain of the inverse cosine? It will be the range of a cosine, which is again -1 to 1, right? So therefore, there's not much you have to learn about inverse cosine. Don't make it like a doubling or tripling of work. If you already know what happened to the sine and cosine, sine and inverse sine, you're gonna do the same thing. But you realize that we did pick a different part of the graph, the cosine, which starts from 0 to pi, and that becomes the range of the inverse cosine. Now, the range of the cosine is still the same as before, just like the sine from -1 to 1. And that becomes the domain of the inverse cosine, right? Again, everything makes so much sense if you start thinking about what we have down to the cosine, right? Now, let's take a look at the graph, right? The cosine graph is, oh, by the way, so the notation is the same, right? So you just call it cosine with a negative power, right? It's not reciprocal, right? It's just a notation for inverse cosine. All right, take a look at the graph. The graph? Right, yeah. So, well, that's why, I'm going to give you the reference sheet in a second. So this is the regular cosine, right? Without the excessive part, we, trimmed it. So now, guess what? You're going to flip, right? X and Y in such a way that the graph's going to be reflected about that 45-degree line, right? I'll draw it over here. Oh. So this is Y equal to X. And I'll do it over here. Unfortunately, the book didn't provide a graph to combine those two on the same grid. So I'll draw it over here so that you can kind of have a visualized, well, make sure that it's 45-degree. Oops. All right, so I'm going to reflect the graph of cosine. Close enough, right? Now, I didn't do anything crazy. I just copied this graph, reproduce it over here, right? So now you see that, indeed, this graph is exactly reflected about the y to the x to get you the inverse cosine, right? It's just, again, it's just taking x back to y, right? Just flipping the input output, right? That's the inverse cosine, right? You guys ready for the last one? The inverse tangent? Well, after the first one, you might be concerned about the inverse cosine, but once you see that the inverse cosine works out just like the inverse sine, right? With just a little bit, fine tuning of the graph. So I'm sure that you're ready for the tangent. But yeah, I mean, tangent graph is a bit scary, right? As always, it has so many different pieces disconnected, right? It has so many, VAs. But you do have to realize that the tangent is 1 to 1 within every single period, right? It doesn't oscillate, but at least that it always rises. That means that we could do a very easy fix of the tangent graph by just taking that center piece, because that's 1 to 1, right? There's no two different values of the angle that corresponded to the same output, right? That's nice, right? So forget about the remainder, because no one's going to take this piece, right? Or that one, or like the off-center ones, right? Take the center one. But here's the thing. Now, if you think that a graph is really helpful, what do you think the graph of the inverse tangent is going to look like if you will reflect the graph of the tangent, including its VA of this 45-degree line? You don't have to tell me right now, but can you picture the graph in your head? And I'll show you in a second, so you see that maybe it does agree with their imagination, or maybe it doesn't. Again, forget about the remaining part. Just that center one, the blue curve, right? That looks like a weird S shape kind of thing, right? It goes from the bottom left to the top right. And also these two VAs. I want you to reflect the graph and a VA of that line, y equal to x. What do you think it looks like? Right, so now let's see if you're expecting something like this. Kind of, right? Now, let's first take a look at the graph. Now in calculus, they're gonna say, you see that the graph is concave up, or let's say in this, at this moment, I'll say that the graph that bends up, right? On the right hand side. So when you reflect it, you can imagine that you just like fold the paper, right, about the 45-degree line. This graph is like bending up. It will bend down, right? And now here, reflect it. It was bending down. It will bend up. Not a big deal. It's the same shape, right? But what about these two horizontal lines? Did they surprise you? And see where they're located. Not a coincidence that they located at negative pi over 2 to pi over 2, right? So now again, think about you folding the paper about this 45-degree line, and there used to be two VAs. We reflect them, they lie down and become horizontal asymptotes. And that's why they have to locate exactly at pi over 2 and negative pi over 2. Okay? And again, everything gets reflected, right? X and Y, even the VA gets, the HA. All right. But like I said, unless, you be referring to the graph, that's one way to deal with the inverse function. So when it comes to inverse tan, you get this graph on the reference sheet. But I'm sure that in a few days, or maybe at least maybe early next week, you're probably going to trash this paper because, it's, oh, okay. Yeah. That's good. But you will see that you probably don't refer to the reference sheet as often as you used to, because it just makes sense. All right. So now let's see if it's not that big of a deal when it comes to the restricted domain of the tangent graph. Again, not all real number, not that kind of a crazy, like almost entire, number line. You only pick the center part of the tangent graph that starts from the first VA on the left of the origin, ends at the first VA on the right of the origin, right? At negative pi over 2 to pi over 2. So you guys realize how close this restricted domain is to the restricted domain of the sign? It looks so similar, right? They are not. Right, so there's no equal signs. The endpoints are not included in the restricted domain of the tangent. That's, again, awful part because, again, like Joanne was looking for something that's consistent, right? Don't you have a restricted range? Don't you have the same restricted, domain? I mean, we wish, but, it didn't happen. Anyway, but look how close it is. That means you have to be careful with the endpoints. Remember that you're not supposed to take negative pi over 2 and pi over 2 anyway, because they're where the VA is located, right? Now, that becomes the range of the inverse tangent. Domain becomes range, right? Well, I guess that you guys are gonna like this better than the domain of the inverse sine, inverse cosine, because tangent complains a lot about the inputs. If you ever type in something into the tangent, let's say if you happen to be a odd number multiple of a 90 degree, or odd number multiple of pi over 2, it complains. You're putting like a 270 degree to the tangent. But since now we're taking a range of the tangent to let it become the domain of the tangent inverse, it takes all real numbers. That means you're never going to get any kind of math error if you type in a number to the inverse tangent. It will always give you something. Okay, you know what? It will even return something if we're putting an imaginary number. Right, so that's how user-friendly it is. Okay, but you have to know, what you're supposed to get. All right. So now let me get you that reference sheet. So that could be something you will refer to either remind yourself what those three inverse functions are. You can even use the graph to take some, no problem, take some educated guess in some of the test review questions. Not that I say in a test, but before the test, you can use the reference sheet to train yourself. Right, yeah. So I might have to report this. Oh, no, no. All right. Anyway, so we've seen this before already, right? Let's try it. You know, just to ease up your anxiety. The thought that you have to memorize a lot of things just because I give you reference sheets, right? You play with that in the homework, 5.7. But now take out your calculator, right? Whether you have a physical scientific calculator or the fancy graphing TI-84 or the decimals, right? Have it in your iPad or on your phone. So I'll give you 2-3 minutes to try all 5. And all you have to do is use the calculator, find a button where it says sine numbers, cosine numbers, tangent numbers, type in the right thing. Now, those options are all angles in radians. So make sure that you know if you're in radians or degrees. If you're in degree, convert it into the radians. But I will say that if I were you, I'll switch to the radian mode. Make sure that it spits out the radians. Go ahead. I'll give you 2-3 minutes. Let's see who can get them all right. Everyone should with the calculator. Make sure you're in radian mode. It depends on which calculator it is. That's yeah. There you go. I wasn't on, right, when Miss Cameron's here. Was it on? Okay. No, okay, no worry. I think I'm safe, you know, in my job. You were good. I should be safe. I think so. Yeah. Yeah. Oh, that wow. Let me. Wish I. Okay, that's degree. That's in degree. How do I go from radians to? Oh, you know what? It's probably here. Let me try this. There you go. That's in radians, right? All right, guys. One more minute. All right, go ahead and finish up with all 5 questions. That's a good question. I am, but the thing is, you know, I'm not the final decision maker. So you know what? I'll pick all those questions on the test, and then they're gonna trash the draft. They all say, no, I'm not gonna do it because you guys don't respect my work. I know, yeah. So that's why I said it. I don't want to make the test. But as a part of the team, I need to do it. Wait, that doesn't sound right. The word has changed a lot. Anyways, let's see. So again, you don't have to raise your hand. I'll let you know what answers are correct, and I want to just be honest. Then when I'm done, raise your hand if you got all the 5 questions correctly. I hope it will be everyone, right? So let's see. 35. 36. B. 37. A. 38. C. 39. B. Now raise your hand if you got all of them right. Okay. Now, see, please trust me. This is meant to be like this. All right. When it comes to English trig, because I've been teaching it for so long, and also I came from science background. This is supposed to be like this. But I know that I'm gonna tell you, which is the truth, but you're not gonna like it. So it's not very likely that you're gonna have those kind of questions in the test. But don't get me wrong, it's not gonna be a question directly asking you to put that in a calculator, but there'll be word problems. There'll be word problems that you have to deal with, weird angles, right? So now, I saw the hand up. Yeah, what was the question? Go ahead. All right, let me see. I think that usually is going to be the mode. Okay, I have to do the shift setup, right? Pick 4 radians, right? All right, guys. Now, in the test, it could be a question like this. You have the height of the building, let's say 100 meters, and you standing here, I don't know, like 200 meters away from the building. And you're looking at the top of the building. You want to figure out what the angle is. Right? Here's what you do. You guys realize that this is tangent, right? Opposite adjacent. You say tangent theta is 100 over 200, which is 1/2. What are you going to do to find a theta? You're asking yourself, at what angle tangent is going to be 1/2? Now you have the perfect tool, because the inverse tangent is going to tell you the angle is nothing but inverse tan of 1/2. So now you guys put it in. Inverse tan of 1/2 is what angle? Tell me either radians or degrees, but I prefer degrees because you can imagine what it is. You can go back and forth, right? Any say it again. Let's say 26, all right? Now, does it make sense that it's roughly like a 20-something degree looking at the top of the building, right? Now, do you see that? It's not a question simply asking you to type it in, right? But you need to know how to do that. Because there'll be somewhere along the way that you need to use the calculator. And that's why you're allowed to use scientific calculator in our second test, right? In all future tests, right? So don't feel like that your work's gonna be ignored. Your work will be appreciated, but not in those easy ways, right? Because if you get those questions, that you feel like that, wait, I thought that I'm way above that level. You guys treating us like babies, right? So because those are baby math, because you don't even do the math, it's the calculator, right? You should function as a engineer, right? Anyway, now one more question before you go. You don't have to try it, but think about that. All right, think about if you could figure it out without a calculator. even though that it's not gonna be, guys, listen. Again, there shouldn't be any question like that because you are supposed to use calculator, right? But if you can figure it out conceptually, that means the test is here, you're here. All right. Now try 32. Well, you don't have to try to think about 32, right? And hopefully, anyone will share with us next time how you figure that out. But definitely everyone should get started with the 5.7 homework.